Okay, let's talk about something very weird, something strange. Let's talk about isolation and container. Let's go. So, first, who I am. Oh, sorry. First, who I am. My name is Quentin Adam. And I have a pretty weird pseudo on Twitter, which is really good because nobody can pronounce it. It was available on all social networks, except an asshole stole it from me on Pokemon Go. So if you find this pseudo on Pokemon Go, it's good for me, just being me on Twitter. It interests me. My day-to-day job is leading a company called Clever Cloud, and what we do is an IT automation system. And IT automation is something that keeps your app online. So basically, as developer, you just git push, and it's successfully deployed in the Clever Cloud. And we maintain everything online. We have what we call application sustainability, which is the ability to monitor, automatically reload application who failed, automatically scaling, fix the dependencies on the bottom of the system. So everything nobody wants to manage about infrastructure, we can deliver it, and it's pretty good because we have all this feature. Big image. We have all this feature on cloud, which is European cloud, strong cloud, or on premise, and we try to give back to the community all we learn about system and everything. So that's why we are here. So don't hesitate to ping us on Twitter or everything, because we're here to help. So, why talking about all this virtualization, container, and everything, and what is important? We need to do some history. First, once computer was big, but have very small capacities. In fact, first computer was big like this room, but have only just a few power of computation, which was really sad because people cannot really use it all the time. But the simple stuff was, if you have the software to write, you write the software, you put it in the computer computes everything, and after you're done. And you don't need to have management or everything. Computer was just a giant calculator or something like that. But the point is, computer have more and more power, so we issue to have many software running on a single hardware. And running multiple software in a single hardware, it's quite complicated because we need to decide who will talk to the processor, who will store something to the memory, and everything. For this, we're creating another piece of software, which is the operating system. Operating system job is basically be able to be sure that everyone is doing his job by this time. It's a precise time of the presentation. I remember that I haven't launched something, so if you can read it this time, you can read it. Okay, so if I'm doing that, so I will start a small virtual machine used for demo, which is using Vagrant. Everyone have used Vagrant before? Okay. During its boot, anyone have heard of Clever Cloud before? Okay. Use it? I still have a lot of work to do. So, can you boot, please? Oh, nice. So, if I plug inside a random Linux machine and looking for a process launched, I will use a command called ps-aux, which is PS is just for viewing your actual processor tree. But if you want to see all the process on the system while root, you can see there is many process. I will reduce a little bit this, close this. So, you see, there is many process, and it's basically the job of your operating system to manage that. In fact, it's so much a job that one of the biggest jobs of the operating system, it's called the process scheduling. And process scheduling is very intense debate. Do you remember the time with systemd, initd, and upstart, and all the fight around that? It's basically because it's important. Systemd win the war, deals end. But the point is, Unix have made a very interesting way to manage who is starting first. So, we lead this to the spaghetti ops management. Do you remember in early, I don't know, 10 years ago, when we go inside a machine and we see, okay, so there is an Apache HTTPD servers with a mod GK able to talk with a Tomcat and a database, and there is some process booted in a screen, I don't know where else, and everything like that. We know that every management of the server becomes more and more complex because we're putting too many software inside the server. And it's becoming quite complicated to understand from the ground up. So basically, what's happening is we try to unlink what was the hardware resources from the software we built. And to do that, using all the process isolation we built, we're trying to think about how to have a proper isolation around this process to be able to say, okay, we know how to manage what we do. So isolation is what? If you're thinking about that, there is few points of isolation between different software running on the same operating system. The first isolation level is the software dependencies. Who have managed a Debian system? Do you remember this weird time when you hit aptitude because you need to install a new package, and because of a weird libxml2 versioning of 2 packets, it managed to have the proposition, if we remove 300 packets and reinstall it in another version, it will work? And you're just like, no, why are we doing that? It's a very bad idea. Software dependency is the problem here. The problem is sometimes we need a version of libxml2, sometimes we need another, and we need to have the same version in the operating system. So have different tree of binaries we depend on will be interesting in terms of isolation between software. The second point is the security. Basically, you don't want that one application can speak to another application without your consent, and more. And this is quite important for what will be coming next. Is it's quite awful that what we can have on some point will be the ability of an application to be corrupted and be able to talk with all those applications of your systems. So basically, you really need a security isolations of all applications on the system. And the next thing is the hardware resource access. When you have a big hardware, everyone is using it in the company, you don't want that the holiday booking apps will be able to consume all the hardware and the real business maker of the company to be done. So this is quite a problem. And this point leads to the whole isolation we need. The point is, we're starting to work with isolation years ago, and the first idea was root. Change root, to be exact of this name, have been invented on the 80s and launched to Linux on the beginning of the 2000s years on Linux. And basically, it's a simple way to think. In Unix, everything is a file. So if we change what is root for a process, it will totally change the way it interacts with the entire operating system. Right? Quite a good idea. Okay. So what it will be done if we're doing that there. So everybody can read that, okay? Now, for example, thinking we have a node application here, and it's starting to use a new application, okay? And we have a server running there. When I see we have a server running there, we literally run the server inside our processor tree. I don't know if you know PS3 launch, but it's the ability to describe what is the processor hierarchy inside the system. So for example, there I have systemd, which is my init process, who will be the father of all process inside my system. And you have several three. And the one which is I am inside is SSHD. I don't want to know why there is so much SSHD, but I have a bash. And inside my bash, there is node running background and my PS3 there. And if I try, I have literally made an error inside my script, able to write some file in the system, because basically I can require any execution. For example, date there have been executed, but more harmful, I can touch any file on the system. So basically, if I'm looking at TMP, I see because right now the process we have the full control of the system. It's launched on top of all the process. If I'm going to use the bind, I will need to be root for some reasons, because I have to mount a lot of things, and I have prepared everything we need inside this directory. So we will mount everything we need there. So basically, there is the proc meta file system, there is sys meta file system, and there is the access to dev, and I will use some binary, so I will need lib, usr, and bin. So okay, now I'm ready to root. Okay. When I'm inside, if I'm doing a PS3. What I can see is I'm inside more and more bash and bash and bash and bash. But more interesting, if I'm hitting to its slash, I'm no more inside root, but I'm inside the root. So I'm thinking at the process, I'm inside another part of the system, and I will be used as a root file system, which is quite good, because if I want to launch, for example, no, it's not the stuff I have been ready for. Just a second, I will take my notes. So if I'm going to root my node system inside it, I will launch it background. If I'm launching the root file system inside it and try, for example, what I have done before, which is, I don't care, which is touching something in the root file system. If I'm looking at it, what's cool, it's not written in the actual slash, but in slash inside MNT basis. So I'm kind of able to jail all the process inside a replicated version of the system inside the system. Everybody is okay with this kind of weird stuff with root? It's quite important because all the container systems are based on root. The point is, the problem with this kind of stuff is, if I root again inside the system, if I hit the moon system, I can really see that I'm based on a root. So if I'm aware I'm on a root, I will be able to root myself in another level, which is the ability to unjail myself. And if I unjail, I'm back on the root file system. So inside a root, you can unroot yourself because you're still root. And root can do everything if it's able to execute some code. The other problem is you need to warn all the binary you will use on your Linux system that you will have some rooting system. Because, for example, if one of the binary, for example, sudo switch user, and be able to do it at the super user something, if it's using the /etc of the rooted environment where I can write everything, I will be able to give myself a password of root and becomes root in the system without having the password. So you need to write down some stuff inside sudo to be sure it will not happening. And it's one of the problems with root. It's not able to do the stuff from the ground up. You need to warn the whole system that you will try to isolate stuff. So it has a weird relationship with root. It's easy to break out from there. And the problem is it may allow privilege escalation in the meantime of it have been done to do not do that. So kind of not satisfying. And it will not be able to manage your hardware resource requirement. So we continue. So we need to continue to improve root. Improve root. Oh, have you heard about all the jails and containers? Basically, it's the same work coming from there, and it's all we will do to make all this kind of stuff working. And the jails and containers are really old. It's OpenVZ, it's Linux vServer, or jails, or any kind of thing, or LXC, and it has been here for years. Who have used LXC before? Okay, cool. And now it's trendy because Docker, runc, rkt, everything is coming back. But just to be clear, this old technology have exactly the same runtime, the Linux kernel. You can write LXC or Docker or anything with the language you want. It can be done with Java, PHP, I don't care. It's not running stuff. It's actually using system call to be able to isolate some process, okay? So just to be clear once for all, when the people of Docker say we used Go because it's a low-level language to write Docker because it has to be performance ready, it's wrong at many ways. First, Go is not a low-level language. If you have a runtime and a garbage collector, you're not a low-level language. Second, it's not actually running. It's only making system call. So you can write Docker, for example, on Python. And the first beta of Docker was Python. So just to be clear on that, all of what we will be talking about container after have exactly the same pro and cons, because it's all running on the same thing, which is the Linux kernel. First, to be able to use containers, we will need Linux namespace. Namespace is a very nice thing. Namespace is the ability for a process to say, this is not true, use this. For example, when you're using root, you're using a namespace. You're using a namespace saying, this is not slash, this is slash. It's just a map of compatibility to get you understanding that. So if you're looking at, we will go to one of our containers we want. Okay, so, oh fuck. Is it big enough? Big? problem is with that. Bigger? There? Everybody can read it? Yes. If there is somebody cannot read it, I'm sorry for him, he has bad eyes. I can read it from my screen perfectly well. So, we will play a little bit with Docker first. So, have you heard of a database called Titan? Titan is basically a graph database able to do a lot of things, and it's basically using Cassandra as a backend storage and Elasticsearch and doing a lot of things. So it's a perfect illustration of a big Docker compose. We will doing a lot of try with Docker machine. So I will eval Docker machine of talk. Okay, so if I'm doing a Docker compose up amp, okay, so we're starting a lot of things. And to be sure of that, we will have a Docker machine talk SSH. So, no, SSH talk. So, we're inside the Linux machine running our Docker, and if I'm hitting that, I see there is a lot of process. If we are going to use a namespace, what will be interesting is to get, yeah, you're running Docker, so basically you're only using process, okay? And your process are just your libraries. For example, you want to find out where is the Cassandra. So I will grep to find Cassandra, and I'm pretty sure it's some starting Java server. Have a class pass. So I have my Cassandra here, and this is the process. What we can see here, it's a process, so it's Docker, it's running root, and you have your Java application running root. Because we're cool, we're doing containers, we are not using the user permission. We're fucked it, we don't use it, no problem. Okay, so I have my PID. If I'm looking at what's inside proc, for this PID, I will find a little subdirectory here, which called ns. Okay, and inside this directory called ns, you have the several typology of what you can namespace inside a Linux environment. First, you can namespace the mount point, so the file system. But you can also namespace PIDs and all the kind of stuff like the user PIDs, the user IDs, the time is it, and the network stuff, and everything. You can namespace many things in the system. And every of these files are basically there. So if you're looking at what's inside MNT, sorry, it will be better if I do that. And then I'm doing that. And then I'm doing that to be able to it have to be a file. Oh no. So when you're using that, what you see is it's mounting a file system point which is different, because it's a link. And other link you will see that we will use at the mount system. And if you're hitting mount, you will find around that we have made a lot of mount inside the system, because we're using IOFS to be able to mount this, okay? So basically, the namespacing stuff on the kernel, it's the ability to put a mask between you and the process for a subtree of the process. And basically, it's exactly there when you can hit the PS3 stuff again, and you will find that we have many Docker containers. We will be child here of the entire stuff, and your Java stuff is running there. So inside a processor tree, you will fake some of the wrapping. And if I'm hitting Docker PS and I have my for example my Cassandra here, if I'm doing Docker exec and I'm trying to get back on bash inside my containers, if I'm doing a PSOX, it will say that the Java is actually the PID1, because it's namespacing the PID to say this is where the PID is. So, okay, do you get what is namespace? Does there is some question on namespace at this time? No, it's okay. So, and you can do it for basically everything inside the system. There is no who I am. No, it's who am I. And it say to you it's root. Yeah, but we are not inside a secure Docker environment. So that's okay. The second stuff everybody is using building containers, it's something called C groups. C groups is not what people think a security feature. All the security features are inside namespace. C groups, it's the ability for a tree, for a special tree of the system to have special quota of using the hardware. The problem is it's not precise. So you cannot rely on C group for real CPU usage, for example, because the kernel have to be the judge and one of the party. And it's very difficult to be the two on the same time. But the point is, C group usage is more to prevent usage of quota in the hardware. And basically, all container systems are using that, plus the capabilities. It's small. It's a really small GIF. Sorry. But it's tiny. It's cute. Okay? The point is, Linux capabilities is the abilities to not give root rights to everyone, but split the setuid possibility to between small capabilities, ability to read directly on the network card, ability to change the time, ability to change the host time. So basically, it's the new age ability of UID to use this kind of stuff. So, for example, if you're using ping, you will be able to get the capability of ping, and you will see it's not using the full root, but only the access to the direct network interface. So if your user is able to access to the direct network interface, you will not be forced to use root to use this kind of stuff. So using all of this kind of stuff, we're building the container. And Linux container are just Linux process. So when a container be sold to everyone, we all see a metal box where things trapped inside. But it's not the reality. It's just neighborhood of all process inside the system. Your process is not trapped. It's just fake to be trapped. But you all share the same kernel. And it's quite complicated because the isolation have side effects. Giving you an example of isolation and side effect. Yeah, for example, disconnect from there. And I will SSH to talk2. Talk2 is another virtual machine I will use to prove what I want to say. I have Rolly 150 process running on top of my machine, okay? It's Linux just started. But the point is, with this Linux, I have several running process. And each running process is somewhere in /proc a set of files, okay? Do you know that every Linux have a limit of the number of the files you can open at the same time? It's the your limit. Just imagine we can have a small fork bomb built with Ruby this time, okay? I'm eating my small fork bomb and it's trying to destroy all the stuff. And if I go to my Docker machine and I starting to launch, I see the number of processes are gradually augmenting. So we have more and more process, and there I can fork, and I'm excited. Why? Not because the machine is dead, but just because you cannot create more process instead of it. Now imagine this kind of side effect at the scale of all you can launch on a Linux. For example, a React database. React database love to open files because they love to have a lot of small files open. Launch 3 React database and you don't know why, but your WordPress server won't be able to create more process and open more files. It's this kind of very weird side effect you can have on the system because basically you're running on the same system than other container. So a neighborhood can be a very big problem. The other problem is you share the kernel. So basically, if there is a problem on the kernel, you can escape. For example, last year, we had something called Dirty Co. Dirty Co is a big fail on kernel, and you can, coming from inside a container, which is a namespace, and go outside and be able to enjail yourself and become root on the operating system. So what is important to remember there, it can become a lot more complex when you're starting to dig inside how an actual system works. For example, entropy. We're all using modern encryption here. Modern encryption requires you to have a real random number generator. But the point is, you all share the same entropy system inside a container system. So basically, if you have a lot of requests on the entropy, you will be able to discover what is the real entropy used by the container, neither by you. And from there, you will be able to guess what is the encryption and break the encryption. The number of system-wide fail possibility are just amazing. So the major point you need to remember is it's cool, we all like it, it's fun, but for third-party code of people who don't know each other, it's a really bad idea. And you need to be really sure of what you boot inside a system, because it's a shared system. And what I say apply to all the system, because it's all the same runtime. RKT, systemd and spawn. Systemd and spawn is very interesting, by the way. I don't know if you have heard about. It's what we come with systemd for managing all the processes tree and namespace and stuff. So it's very interesting. So it's one of the very big impact. When you're thinking about container, just think also to the Linux philosophy. Keep things small and simple. I don't think a binary of 80 megabytes containing a Docker, the Docker engine, a server, but also a reverse proxy and no Kubernetes and everything is something, keep it simple and stupid. It's kind of the Swiss Army knife, but poor like that, you know, like, yes, I can cook with my Swiss Army knife. It even have some tools to break to the, I don't know. It's very wide, you know. So does it respect the Linux philosophy? It's important. The other problem is about the PID one. When you are on Linux, there is only one PID who start the process and manage the life cycle. When I say manage the life cycle, it's starting and stopping the process. It say, okay, it's a good idea to start the process. It's killing the zombie, everything. When you're using Docker inside your system, you have a second kind of PID system acting just in the neighborhood of systemd. And basically, they fight each other all the time. It's very boring. So that's why rkt and systemd and spawn and all this kind of stuff are very interesting, because they are on the Linux philosophy. So if you want to build some container into production, you should pay attention to this kind of stuff, because you will have a problem of PID. You have another problem, it's inside the container. Like we see, the Java was thinking it was the PID1 process. Try to attach a G-console to something we think is a PID1 process, good luck, because it will never be agree with that. Being the PID1 process is a lot of responsibility, cleaning the stuff and everything. So the problem is, inside this bubble of a container, you need to assume all these responsibilities. And for example, server like Unicorn and this kind of stuff, we have a lot of responsibility of creating and killing process. It can be a nightmare because it generates a lot of process zombie without anyone to kill it, which is a lot of big problem. So this is kind of complicated stuff. The other point I want to just say before I move to explaining what is a virtual machine, it's the relationship between the kernel, the operating system, and everything. Inside the kernel, inside the GNU operating system, there is a kernel, but there is everything else. And for example, majority of software are based on top of something we call the glibc. GNU general libc we all use. It's a standard C library we all used. Do you really think that a combination untested of the glibc and the kernel is a really good idea? Basically, when you're building a container inside your laptop and send it to the production, you are basically making exactly that. A combination untested of the glibc and the kernel, which is far worse than having an untested combination of Spring Boot and the Java virtual machine. Because basically Spring Boot have planned to have multiple Java virtual machine. So when you're building container, just trying to think, do I really need to stack all the dependency to that or not? Which is a very important choice. I already talked about shared kernel and about unikernel in the question if we have time. The last point we need to talk about is the monitoring. The monitoring is digging inside every part of the system, /proc, /dev, everything. And the point is, you cannot launch a monitoring inside a container. So you have to monitor all your process from outside the container and reconfigure the monitoring at launch. So it will be a huge work to actually monitor what you do inside the system. That's why at the beginning, before Docker, we forget about the ability of the isolation and searching for another thing. Years ago, sorry. Sorry. Okay. So years ago, it was something called emulation. Who have ever used Dolphin to make, an Xbox? Okay. Dolphin is actually not launching an Xbox inside your computer. It's emulating that there is a CPU of a GameCube inside your computer, put an operating system of it, and running it. It's emulating stuff. It's exactly like that work QEMU. QEMU was written once by someone very clever called Fabrice Bellard. It's a guy you maybe know it. Do you know Fabrice Bellard? Fabrice Bellard is a pretty interesting guy. The first thing he does was very interesting. There was a Japanese group using supercalculator able to manage to break the number of pi decimal they have built. And Fabrice Bellard reads the press release, reads the code and say, maybe we can do better. He have done an entire new software inside his desktop. And 2 weeks after, he breaks the numbers of pi decimals in his regular desktop computer. You have also write something called FFmpeg. I don't know if you know it. So, this guy is pretty brilliant. I hope someday I will meet him and just have a check-ins with him. A very, very impressive guy. And he have write something called QEMU. QEMU is the ability to emulate the presence of something which is actually not here. It's very wholesome because you can have an actual ARM processor inside your laptop without having an ARM processor and just be able to, for example, to compile inside ARM and make some tests and everything. But it's slow as hell because you need to emulate everything. In another room, all this guy was working on something called Xen. Xen is para-virtualization. Para-virtualization is a very, very complicated word because everybody is using it for different kind of things. So beware of para-virtualization. And Xen is about to launch a very small system, able to launch slightly different Linux kernel. They know they are virtualized, but they will act like maybe entire operating system. And it's what Xen brought to us, the ability to launch an entire Linux system like a process. And then something break all the thing, it's Intel. They have brought to the entire infrastructure something we call virtual transaction instruction. And it's a VTX instruction you have inside your CPU. And what is a VTX set of instructions? It's the ability to run two separate operating systems without each other know they are running virtualized. So basically, the virtual system, each operating system don't know there is another operating system. They don't need to be edited. They don't need to be changed to be virtualized because it's a processor instruction which just change the context of the processor. What is really awesome in the stuff, it's you have also the thing inside this instruction to just manage access to different hardware. At the beginning, Intel was thinking that we will use a big Intel CPU and have 10 network cards inside the servers and attribute each network card to someone, which is absolutely not what we do because it's not the way we want to enter, but it seems to be very interesting anyway. So basically, the access to the hardware is really interesting this way. And now what we do is using a plain old operating system without noticing that is virtualized. So you're using an entire operating system without knowing that it's not alone on the CPU. The problem with that is we don't have servers with thousands of network cards. Today, what we do is using stuff to be able to virtualize the network cards. So we emulate an entire network cards, and we have virtual switching, and with only one network cards, we give networks to each other. But the basic idea was there. And it's perfectly isolate everything because you have an entire operating system. The isolation is not guaranteed by code, but by hardware. And the hardware resources access is managed by the hardware also. So it's very interesting. But the point is, people are complaining about performances. The point is, everyone has the experience of virtual machine using VirtualBox. And VirtualBox is slow. We all know that. But why? It's not slow because the processor is slow. It's slow because the display is slow. Because to be able to display something on VirtualBox, you need to emulate a graphic card, then emulate a screen, and then redisplay the screen on top of your laptop. So basically, the way to just print you something in your laptop, it's very long and complicated. But what we do on the server doesn't need that. We only need access to the hard drive and the network. And from there, we have developed very interesting stuff called the VirtIO, which is a direct communication channel between a virtual disk on top of the machine virtual, on top of the VM, who actually talk to the host driver of the network card or the hard drive. So you have absolutely no loss of performance on the I/O with this kind of stuff. What is interesting is people say to you, yes, but you cannot launch so many no, I have no big, can I have like this one? Yeah, sure. You cannot launch so many virtual machines. So, for example, just going inside a KVM server we used for test at Clever Cloud. If I'm looking at PSOX, I will see there is a lot of, it's a little bit big. Still readable? Perfect. So you see there is a lot of KVM, but the point with all this KVM is you cannot see what's inside, because the KVM stuff we just launched is just the ability to say to the Intel processor, okay, we will launch another OS in another context. So you cannot dig inside the process of the virtualized operating system, because this operating system is unable to see it. It's real isolation of all the system. And people say it's complicated to launch a lot. This is just a test server. So just grab some. How many there is? Oh, nearly 200 in just the server. So you can launch a lot of virtual machine inside the same server because you have lots of room disponible in the CPU. So what is important there is to understand what is your bound in terms of performances. Does your bound is the RAM? I don't think so, because RAM is very cheap now. Does the bound is the CPU? Do you really burn CPU? I don't think so, because I host thousands of applications and I never see an application CPU bound. Your real bound in the I/O. And the I/O is the ability to read on the hard drive and read on the network. And the old stuff is really important to do that. And when you're using containers, you're using proxy for all your I/O. So basically, you're less performant inside a container than in a virtual machine, which is tricky, isn't it? At this time, we have a lot of tests, and benchmark on the internet about Docker versus virtualization. All the test was running using the Docker --host option, which say disable all the binding on all the proxying on all the security of Docker and using no proxy to do it. But you're never doing this in production release. Sorry? It's used a proxy. inside the Linux kernel. It's no more a Docker proxy, but you used you have to proxy all the call.
It happens within the kernel itself.
Yeah, but it's still slow because it's on the user land and not on the kernel land. So it's basically very interesting to work on all the hardware allocation. It's quite complicated to read it like that, but it's the hardware allocation is the very short. So if you're looking at all the VM and containers and everything, you have to think that it's kind of very complicated stuff you need to do. And first, you need to understand that containers will never be native on your laptop. When Docker say, with Docker for Mac, we have built a native version of Docker for Mac, it's more or less true. Just giving you an insight. I will run an Alpine or something. So I'm using Docker for Mac. So I will run an Alpine, okay? I have my Docker running an Alpine. Let's go. But if I'm hitting here to find my Alpine, I will never find it. Why? Because it's not running on my Mac. It's running inside a virtual machine. In fact, you can access to the Docker virtual machine on your Mac. It's a little bit complicated, but it's sitting on the TTY is sitting on one of the file inside your Mac architecture, and it's very beautiful. In fact, it's used a very beautiful virtualization framework called bring by all the Apple infrastructure called HVKit, and it's very interesting. And there, if I'm there, I will find, oh, it's a Linux. It's a Linux Moby running on my laptop. So basically, I'm really using a virtualization everywhere because let's be sure, your containers are just binary. So you cannot launch a Linux binary inside your Linux and it will work. It will never happen. Same thing for Windows. Or you're using kind of wine-like technology. For the people who have used Linux for real, you remember Wine to try to play two games. How many have been successful to play their games in less than 5 minutes with Wine? What games?
Self-written games.
So it's kind of very interesting to just remember that virtualization and containerization are not enemy. It's working together. At the beginning, Docker have been done to run on top of Amazon, which is only virtual machine. So you cannot just oppose the two technology. It's have to work together. I think I have absolutely no time to speak about Kubernetes, Nomad, and Swarm, and everything on the orchestration. But basically, what I explain is the orchestration feature it's a viable. You can work with orchestration with virtual machine or containers. It doesn't change. The point is more like automating your infrastructure. And automating all the stuff is not about using tools. It's about a process in your team. Basically, it's what we sell at Clever Cloud. Automation on our cloud, on premise. But the point is, we're not using containers. We're not using containers to doing that because we cannot afford to have third-party application of people who don't know each other running on the same operating system. It will be dangerous. So we're using virtual machine. We have a lot of improvement in the boot system of the virtual machine. We have, from the time we asked our orchestrator to boot a virtual machine, from the time it actually say on the network, I am deploying the application of the customer, it's about 7 seconds only. So you can have really fast virtual machine if you're not Amazon and you know how to configure KVM. But the point is, you can work on this kind of stuff. So you need to automate the stuff. Not going to Docker for going to Docker. Just automate stuff because it can be interesting to do things like that. From my point of view, if I was you, I will not use container for all my application, even if I am the same customer, self-customer, because I think that every application can be broken, and if the application is break, it becomes rogue, and I need it to be totally contained, because I think there is absolutely no fortress in my IT. It's only piece of things we can be broken by an attacker. If you want to go after Docker, please be informed about all the Linux low-level dark magic. How many of you have read the Linux changelog for the past 10 years? Please do it. You want to become a real Docker expert? Do it. I have two websites for you. One is lwn.net, which is the place where you can find the actuality. It costs you $7 per month, but it's worth it. Like definitely, it's worth it. And the other website is Kernel Newbies, because basically the actual changelog of Linux is maybe readable by Linus, but not for poor human like me. And I'm actually using the resume and the making translatable for human of the people of Kernel Newbies who do an awesome job. So basically, using the two websites, you can be really informed about what is doing inside Linux low-level dark magic. And now, for example, just discover how works Alpine. Alpine is so cool. Who is using Alpine in production? Okay, just explaining to you what is Alpine. How do they make Alpine so small? So just remember, we are speaking about choosing a Linux distribution not because of the intrinsic qualities, but just because it's small and we're using Wi-Fi on our laptop and we don't want to have big containers going down from the internet. So I think it's a very poor reason to choose a Linux distribution. But anyway, all that they do to make Alpine so small, they remove all the things not necessary to make Linux running. That's it? No, they remove more. In fact, at the beginning, Alpine was built on top of Muzzle. Muzzle is a replacement of the glibc, written by 3 guys, and able to be the replacement of the C standard libraries. And if you're looking at the Alpine website with the package, you see that all the package are maintained by 1 people, bus factor 1. And it's maintaining all the package. And now you're saying to me that you're using Docker for have exactly the same code from the laptop of the developer to the production to be sure there will be no problem. Okay, so do you think that the people who develop PHP, Java, MySQL, Postgres, and all the tools you're using are testing against Muzzle or glibc? This kind of little trick when you're doing and digging in Linux low-level dark magic, it's the important things to know if you want to go on production with this kind of stuff. So I'm not saying don't do that. I'm just saying learn that. And if you want to learn, you need to understand the point. So I will speed because I'm very, very, very late. So I will not speak about the dependency limits, but it's what I was trying to explain you before, that maybe if you're just deploying a Spring Boot application, it can be good to just like furnish a jar and not an entire system, because basically Spring Boot is managing to have multiple Java. It's not needed to have a precise version of Java to work. And maybe your precise version of Java is a complex problem. Because, you know, giant binary everywhere, I don't think it's a good idea. You know, like we tried before, it's not a success. So just be careful of this kind of stuff. Even if you are in a kind of complicated company where you need to have like DevOps or Ops Dev. You know, like a lot of companies are deploying Docker because developer wants the power to deploy what they want. So be it. And the Ops. I know Ops can sometimes be tiring, but they have some job to do. And for example, when they need to understand how an application works before putting it in production, it's because when it will be failing, they will know how it works and be able to restart it. If you're just giving them a Docker and I don't care about, what will be happening at the first break? They will learn. And you don't want them to learn how it is working once it's done. You want them to learn while everything is okay. So it's a very important point to understand about the containerization. It has to be a way to make your team a better way, not to do the developer will be the job of the ops on top of their jobs, which is a really bad idea. And by the way, it's complete nonsense. Everyone is going to be an expert, not the other way. When you go in a castle in the 12th centuries, you have one guy. He talks Latin. It doing the medicine, in making the money management of the land, everything. It was the men who know what the humanity know. Okay, but today it's not the same guys. It's the same guy who can create new implant for your brain, launching rockets in the stars, and creates electric cars. Oh fuck! It's the same man, but. Except from Elon Musk, it's expert job who actually need to be precise and be done by someone who actually dig inside the stuff. So don't use containerization to build a developer who actually makes the job of ops on top of his job. Use the containerization to have a real DevOps tools, which is the fusion of tools and of jobs and not jobs. So please remember, container and virtualization are totally different stuff. So we never say container are just like virtualization but more light, because it's false. The container isolation is bad, and it's exactly the same that making PHP mutualization in top of your server, except everybody is bringing his own binary there. If you want to do Linux dark tricking, learn the Linux dark tricking, and there is good stuff to learn around. You can have a lot of fun using container, and there is never a panacea to build your IT. There is no silver bullets in the world. There is only tools you can improve your work. So thank you very much for listening me. I know I'm late. Please try Clever Cloud with with this coupon and not the one written before. And I'm available for questions. And I have also a very cool sticker. Thank you very much.